Welcome to eLUXE3D. What you're seeing on screen is the final product of a necklace and a pendant that was designed starting with an irregular gemstone. This demonstration is going to walk you through the process of using an eLUXE3D scanner in collecting data and building a three-dimensional virtual model that can be exported out as an OBJ or an STL into your desired CAD package. The designs for this piece were done in Matrix. Can also be done in Rhino, various other CAD software packages that you use as a jewelry designer. Let's get to it. eLUXE3D scanner in action, scanning an irregular gemstone. Multiple orientations ran by a full macro that's fully automated. Data showing as it was being acquired live. The stone is placed into a fixture in a single orientation. Approximate scan time is about 2 to 3 minutes. Stone is flipped over and we collect the missing information and ultimately have 2 groups of scans. The next step is going to show the alignment and post-processing. This video or demonstration will show how to align 2 different groups of scans within the EasyScan software. If you look at the model tree here, I have group 1 and group 2. So basically what happened is I took this irregular stone and fixed it into a position and ran 15 scans, which were fully automated in this orientation. So if we look at the bottom of this stone, you can see there are some holes. With the eLUXE3D scanning technology, the system will actually collect data and what it can see. If it can't see information, if there's hidden features, it will actually not scan that. So an object like this, that we need a fully watertight model, we would have to flip over and collect data on the other side. So that's exactly what we did. We flipped that stone over, put it back in the fixture, and collected another 15 scans from position B. This gives us 2 groups of data with 30 scans total. Scan time for something like this is approximately 3 to 4 minutes. So it is very quick, but it is very accurate, and it is very accurate with a high degree of resolution. So now we want to go through and basically clean this information up. We want to delete some of the fixture and then go through and align the 2 groups together into one 3-dimensional object. So let's go ahead and turn off group 2 and we'll just work with group 1. I will go through and basically just delete the areas I don't need. If you do grab a little bit of your object, it's okay, because I know that in this instance I have this information collected in my position 2. We'll go through and do the same thing for group 2. Fixture we don't need. We'll highlight that information, circle around that area, click on delete. So now basically I have this stone in 2 orientations, group 1 and group 2, but they are still not aligned. We've got to give the software some information about how these 2 go together. So what I'm going to do is I'm going to click on group 1. I have some icons that become active here for me. The very first one is going to be what we call the manual alignment. This manual alignment will split the screen in 3. Down in the bottom I have the object that's considered fixed, which is my group 1. That's the data that I selected, and then it's asking me which one is the moving, which object you want to move and snap to group 1. So we're going to do group 2 because we don't have an additional group, but if you did have group 3, 4, or 5, you're able to kind of stack these up and align them in the right orientation. So now we want to we'd like to go through and figure out approximately how do these guys go together. So based on the way this was scanned, I know I have some common features I'd like to try and overlap. For example, if I look at my object in this orientation, I know that this wall here is going to be this wall here. So I'm going to guide the software by selecting some common areas. For example, we'll say this corner approximately here. We'll say this back corner is approximately there. You can see on the result preview how the software is interpolating or grabbing the areas that we're selecting and bringing these scans closer together. Let's do one more and let the software take over. Let's just say approximately this area is approximately there. This is close enough. Even though it's not perfect, when I go through and click on the apply button, what the software is going to do is calculate the change in curvature of the common areas and do what's called a global registration and snap them into place. So you can see how quickly it did that and basically did an alignment between group 1 and group 2. We're going to say close, and yes, we want to apply the changes. So now I've basically aligned group 1 and group 2 into one three-dimensional model. In this case, I'm going to go through and grab all my data from group 2, just drag it into group 1, delete group 2, giving us one group with 30 scans. A secondary process that we always like to do is do a global registration. So that would be the next step. By selecting my group, I have this icon that's also active called Global Align. What this will do is this will take all 30 scans and do a final global registration of all scans individually. And down at the bottom, you can see the global alignment is complete. The average distance is about 6 microns between all 30 scans. So again, it's very accurate. The resolution of these scans is very high. We're working with approximately 3.5 million raw vertices, so raw points. So it's quite a bit of data that gives us this capability to align everything. Once the alignment is complete, we're going to go through the next step, which is going to be our merge. Now, the merge is what's going to ultimately give us the capability to take all the individual scans, merge them into one large object, and export that as an STL or an OBJ. We do have some resolution control here, whether we'd like a standard resolution, high definition resolution, or an ultra high definition resolution. And this is basically some algorithms that the software uses in the background to decimate the actual model for polygon or STL size functionality. So we can talk about this at a different time, but at this level we'll go through and let's just go ahead and use the standard definition. And what I'm going to do is tell the software to create a watertight model, which means if it finds any holes like this hole in here, even though we have a deformation in this particular stone, it will go ahead and close that hole, giving us a watertight model. So we'll say apply. The merge is in progress. This should just take a few seconds. If you guys are curious, I'm just running on a standard Microsoft Surface Pro laptop, so I don't have a high-end, high-powered machine, a CAD station or anything like that. Obviously, the more RAM, the quicker this would run. Okay, there we go. And this is basically what we're seeing is the final STL or OBJ. That hole is preserved. This is a watertight model. We have approximately 750,000 polygons. If we zoom in and take a look at a different format of view, like for example our triangles, you can see how tight these triangles are. What a beautiful model we actually produce. This stone is approximately, it's approximately 20 millimeters by 25 millimeters, so it's not a very large stone by any means. And that is the alignment process in the merging process. If we wanted to go through and fill some holes, decimate, things of that nature, we have that full capability. But in this instance, I'm basically going to right-click on my group 2, which is now my STL, say export, and I can select whether like an STL, OBJ, PLY, ASCII file. Most common would basically be the STL or an OBJ. We have two different formats of OBJ. If we're scanning in color, we can export a OBJ that contains color values for specific objects. So I'll just select STL, and we will go through and save this to the desktop. We'll call it Irregular Stone. And that is it. So scan time on something like this, 3 to 4 minutes. As you can see, the processing time and alignment time is with me speaking and walking through it very slowly, about 5 to 6 minutes, and this can definitely be done a lot quicker with use. But that is a quick demonstration of how to take a regular stone and scan it in 2 different positions, align it, and quickly export it out as an STL, OBJ, or an OBJ. You can visit us on eLUXE3D.com for additional information on all of our scanning technology. Thank you.